This video will demonstrate how to use the standard template library's set class. Hello, I'm James Helfrich. The set data structure is a really convenient tool to keep track of a collection of things where we don't care about the order, we just really care about adding and removing elements and querying whether an element is in there efficiently. This video will demonstrate how to do all those things.
There are several different ways to construct a set. The default constructor, the copy constructor, the move constructor, the initializer list constructor. In each case, we must specify the data type of the underlying data structure, the T, but we also get to specify the comparison operator. We'll see how that works in just a second. Okay, so we need to start by pound including the set library. This gives us access to all the code involving the set. So we say pound include less than set greater than. Now we'll start with the default constructor. Now the full name of the set is std::set, and then I need to specify the data type, in this case int. So I'll call my variable s for set, and when I look at it, they're going to be of size 0, which is kind of what I expect. Notice how by default I'm using less than to order the elements in the set. Now, I can also use the initializer list to initialize a set with a collection of elements, 4, 8, 1, and 3. Now, notice that the order 4, 8, 1, and 3 is how we put them in, but when I open the set, we're going to discover that they're in sorted order, according to the less than operator. The set will order things in the way that's most convenient for retrieval, addition, and subtraction. Now I can also specify the order in which things are. By default it's less than, but now I'm going to do greater than. When I do this, I expect the same numbers to be sorted in the opposite order. And sure enough, 8, 4, 3, and 1. We can use any comparison operator we want for this. Okay, so what I want to do now is I want to copy from one set to another using the copy constructor. So I'm going to say set source is 4, 8, 1, and 3, and set int s destination is, well, s source. And I expect both source and destination to have the same 4 elements. And when I run it, sure enough, they have the same 4 elements. So I made a copy of it. Now I can specify the move constructor with std::move, and this means that destination is going to steal source's data. When I'm finished with this, source will have no elements and destination will have 4. So when I run the code, sure enough, destination has 4 and source has none. There are several different ways to use the assignment operator. There's the copy assign, move assign, initializer list assign, and I can swap the contents of 2 sets. So I'm going to start with 2 sets, 8, 4, 1, and 3, and the second one has 10, 20, and 30. And when I say use the assignment operator, now I'm going to copy the contents of source into destination so both will have the same 4 elements. And this is the copy assign. Now if I say std::move, now I'm going to use the move assign. And this means that the 4 elements from source are going to get copied into destination and source will be empty. So now source is empty now, and destination is going to have the 4 elements. Now I can also say std::swap, and this is going to swap the contents of the source and the destination. So now source is going to have 3 elements and destination will have 4. And sure enough it does. Okay, so I have several iterators, a forward iterator, a constant iterator, a reverse iterator, and I have the usual begin and end. Let's see how they work. Okay, so I have the same set of 4 elements, and now I'm going to create an iterator. The full name of the iterator is std::set::iterator. And I'm going to call it it for short. And it equals s.begin. So I expect it to point to the first element, which would be the value 1. And sure enough, in the debugger, it points to the value 1. It points to 1. Okay, what else can I do here? I can also advance the iterator. Oh, actually, the short name is auto. Now, when I say auto, I'm going to let the compiler figure out the full declaration name. And that's a really nice convenience that was added in C++17. Okay, now I can also increment the iterator by 1. In this case, it will now point to the value 3, which is third in the sequence of the set. And sure enough, it is. Now, the most common thing we do with a set is we iterate through all elements. For auto, it equals s.begin, it not equal s.end, plus it. This standard for loop we use for every time we want to walk through all the elements in a collection. Now what I'm going to do here is I want to change the value of each one by multiplying it by 10. All right, when I run this, I'm going to get something really unexpected. I'm going to get a compile error. Why is it a compile error? Well, remember the set maintains the order of the elements, and so if we're allowed to write to the set this way through the iterator, then we can change the order in validating the less than constraint the set is built around. So we can't really do that. Our dereference operator is read only, so in this case, rather than change the element, I'm just going to sum them up. And so 1 plus 3 plus 4 plus 8, what's that going to equal? 16. The way to access an element from the set is using the find method, and this will return an iterator for a given t. Of course, it'll return the iterator to end if that element does not exist. Okay, so I'm going to make an iterator it equals s.find, and I'm going to find the value 8, and we'll see if it will point to 8. And so sure enough, when I run it, then it's going to point to 8, and there it is, pointing to 8. We insert elements into the set using the insert method. We have the copy insert, move insert, and we can even insert a whole collection of elements at once. So I'm going to start with my same 4 elements. I'm going to say s.insert, and I'm going to insert the value 5. Now remember, the set maintains things in sorted order, so I expect it to be after 4 and before 8. And sure enough, it is. Now the cool thing about set is I can insert a whole bunch of elements at once. So here I'm going to use an initializer list, 10, 20, and 0. And so I expect the output to be 0, 1, 2, 1, 3, 4, 8, 10, 20, because it's going to be in sorted order according to the less than constraint. So there's the value 0, and there is 10, and there is 20. Okay, we can erase elements using the erase method. We can either pass the t that we want to erase, or an iterator, or a collection of iterators to the values in the set we want to remove. So here I have the same 4 elements, and I'm going to see if I can erase the value. Which value should I look for here? How about the value 3? But I want to see what the return result is, so I'm going to say size t, the value equals erase. Now this is going to return the number of elements that was erased. And since 3 is in this set, then when I call erase, I expect there to only be 3 elements left, and then we expect the size, the value to be 1. In other words, I erased 1 element. But now, if I try to erase a number that does not exist, then the set will still be a size 4, and I expect the value to be 0, which is I've erased no elements. The last thing I could do is I can also pass an iterator. And so what I'm going to do here is I'm going to create an iterator of, let's see, the first element, which should be the value 1, and then I'm going to attempt to erase it. Now, what is the return result going to be? It's going to be the result of the next element in the sequence. And this would be useful if I want to remove more than 1 element. So I expect when I'm finished with this, then the 1 will be removed, and it new will point to 2. And sure enough, it points to the second element, which is 3. And of course, the set provides the usual status methods. Size is going to return a size t, indicating the number of elements in the set. And empty will return a Boolean, which was true if there is at least 1 element in the set, and false if there are none. And so when I run this, I expect size to be 4 and empty to be false. To learn more about the set, take a look at the C++ Data Structures textbook.